All right, so raising a product to a power. So this one we kind of already touched on back when we were looking at product rule. So for any real number a and b in an integer n, if we have a times b raised to the power of n, well, basically we can distribute that power across and we have a to the n times b to the n. So I do have an example here, but I'll write another one off to the side. So let's say we had 3x and we raised that to the power of 4. Well, that's just 3x times 3x times 3x times 3x. So if we counted, put all our 3's together, and then put all our x's together, then we're going to get 3 to the power 4 and x to the power 4. So like I said, we could just cut to the chase and just go, oh, I could just distribute this power across. Okay, so examples here. So in this case, like I said, just make sure that this goes to every single number. So we are going to have 3 and this 4, power 4 goes here. So 3 to the power 4. Where we have x to the 4, but I'm also raising that to the power of 4. I also have y to the negative 5, but I am raising that to the power of 4. So what I'm going to have here is I am going to have 3 to the 4th, so that's going to be 81. I have x to the 4 to the 4, and if you remember by that power rule that we had, that is just x4 times 4, because I'm multiplying my powers. I have y to the negative 5 raised to the power of 4, so that's just y to the negative 5 times 4, or 81 I keep writing that one right on that line. 81 and 4 times 4 is 16, so x to the 16. And then we have y to the 5 times 4, so negative 20. And then because we want all my exponents positive, this is 81 over x to the negative 6. And just remember that this goes on the bottom, and we get y to the 20th. And then it's simplified. There's nothing more I can do. All right, this one's going to be a little weird because it's not weird, just a little thing to consider here. So this is a negative 2, right? Negative 2 to the power of negative 3. Then we have x to the negative 3 to the power of negative 3. This is just distributing this power on the outside. I have y to the 5th now to the power of negative 3. So I'm not going to do anything special with this yet. I'm going to leave it like this. Get rid of that line there. So here we have x to the negative 3 to the negative 3 because we're going to multiply those exponents. We have y to the 5th times the negative 3 because we're multiplying these exponents. So I still have negative 2 to the power of negative 3, x to the 6th, y to the negative 15. And as I said, always think of this over 1. So everything with a negative exponent goes to the bottom. So x to the 6th stays here, but because that negative power, I get negative 2 to the 3rd down here. And I'm going to have y to the positive 15 down here. So notice that the only thing that changed from positive to negative is the exponent. I still have that negative 2 there. So we're not 100% done yet. We got one other part to this left. So I have a negative 2 cubed. So that is a negative 2 times negative 2 times negative 2. So multiplying 3 negatives, we keep negative. 2 times 2 times 2 is 8. So my -2 cubed on the bottom is actually -8, and then we keep that y to the 15. Like I said, it's just one of those things you got to keep track of, is that, well, for one thing, when my exponent is negative, I have to make sure my exponent is positive so I can even do this part here. The other part of this is that you have to remember that when you're moving your portion from the top to the bottom, that what you're doing is you're changing the exponent from negative to positive, or vice versa if you needed to do that. That's the only thing that's changing, is the power on the sign on the exponent. Nothing else changes from positive to negative. All right, so for number 10, so just pause this for a minute and just attempt these ones here. And then we're pretty close to being done with this whole section. Okay, so we have 2 times a times b to the -2, all raised to the power of 4. That 4 distributes everything, so we get 2 to the power 4 times a to the power 4 times b to the power of -2 raised to the power of 4. So 2 to the 4 is 16. When we keep a to the 4, and then this is just b to the -2 times 4. So this is just 16, a to the -4, b to the -8. And once again, because we don't like that negative, that's end up going to be 16. I'm gonna write this under here. 16 a to the 4, b to the +8. All right, so for this b, we have -x. We're going to talk about what we do with that negative. So one of the things I said before is that negatives, you just have a negative that represents a -1. So this is really just saying that I have -1 times x times y to the power of -2 to the power of -1. So it's the -1 is getting a power of -1. The x is getting a power of -1. The y to the -2 to the -1 is getting power to the -1. So we'll start moving things around after we simplify this part. But we got -1 to the power of -1. We have x to the power of -1. And then you have y to the power of -2 times -1. So this is just -1 to the power of -1, x to the power of -1, y to the power of 2. So everything with a negative exponent, I'm bringing to the bottom. So we have -1 now to the power of +1. We have x now to the power of -1. So -1 to the power 1 just stays -1. So we're going to keep that negative, and then we're just going to have that x. Oops. Color have I not used? Who's the dark red? Burgundy. So for C, we're going to have 3 to the power 3. We'll have x squared to the power 3. We're going to have y to the -1 to the power 3. So 3 times 27. 3 times 3 is 9, times 3 is 27. Then we have x to the power of 2 times 3, and we have y to the power of -1 times 3. So that is 27 x to the power of 6, y to the power of -3. Or 27 x to the 6 over y to the power of 3.